All right, lesson 2-2, proportional reasoning. Doing the entire section tonight. Classwork's going to be split into 2 days, though, so this video is going to be a little bit longer than, the goal of 12 or 13 minutes, but you only have to watch one over the next 2 nights. You're going to learn how to apply proportional relationships to rates, similarity, and scale. Okay, when we say similarity and scale, that's our geometry examples. And we have our vocabulary right here. Indirect measure is going to be shadows and similar triangles. First, a ratio is a comparison of two numbers by division. If we have a proportion that is an equation stating that two ratios are equal, the cross products are equal. So here I have an example. I have two ratios equal to each other. If I do the cross product, I cross up, and I get 3 times 15 is 9 times 5, 45 equals 45. First example, solve 16 over p equals 24 over 12.9. I'm going to do the cross product. 16, let's try to write that a little bit better. 16 times, 12.9 equals p times 24. Let's actually do 16 times 12.9. Calculator out. 206.4 equals 24p. Divide both sides by 24. I get p equals 8.6. Another example. Okay, solve. Cross product up, do some multiplication. 88c equals 14 times 132. Okay, multiply. I get 88c equals 1,848. Solve for c. Okay, you try the next ones, the next two actually. Go ahead and push pause and try them. There you go, 2 answers. I did the cross product of each and solved for the variable. Alright, because percents can be expressed as ratios, you can use the proportion percent over 100 equals part over whole to solve percent problems. This right here is a very useful equation that you can use for any percent word problem. It's just really useful because you just plug things in. Remember, 30% is the same as 0.30. You just move the decimal place over twice, which is the same as 30 over 100. So when you're given a word problem with, say, 30% in the problem, you're just going to plug in 30 in the percent spot and keep the 100 there. You don't have to convert anything. First example, a poll taken one day before an election showed that 22.5% of voters plan to vote for a certain candidate. If 1,800 voters participated in the poll, how many indicated that they plan to vote for that candidate? Okay, I have percent. I have 1,800 voters, that's our whole, and we are looking for the part. Okay, that's our variable, and that just stays. Let's do some math. Just plug in the number as you see it. Equals x, because we don't know the part, over 1,800. Do some cross multiplying up. And you're left with, get the calculator out, 40,500 equals 100x. Solve for x. X equals 405 voters planned on voting for the candidate. Oops. Voters. Nice. On your own. At Clay High School, 434 students, or 35% of the students, played a sport. How many students does Clay High School have? Set up your equation. Okay, percent over 100 equals part over whole. You do it. All right, set up your percent over 100 equals part over whole. There's 35% that play sports, or 434 students. How many are in the high school altogether? Set up your proportions, do some multiplication and division. You have 1,240 students total. All right, a rate is a ratio that involves two different units. Okay, it's a ratio where we do, why does it keep doing that? Oh, for goodness sakes, there we go. Miles per hour, words per minute, or dollars per gallon. That's what a rate is. We always have word problems involving rates. So here's our first one. Ryan ran 600 meters and counted 482 strides. So for 600 meters, he counted his steps and he got 482. How long is Ryan's stride in inches? So we need to set up our rate and then convert it from meters to inches. So we do. He has 600 meters per 482 strides. I'm going to abbreviate ST for strides. Okay, so how many meters is in one stride? Do your cross product. We get 600 equals 482x. Solve for x. You get x equals 1.24 meters. Now, what is Ryan's stride in inches? 1 meter equals 39.37 inches. I'm hoping you learned this in science class. If not, we'll do some more examples. If I want to convert meters to inch, I set up a multiplication with fractions. Okay? It's just like having this over 1. I want to cancel out my meter, so I have an m in the numerator and an m in the denominator. And I want inches in the numerator because these will cancel, and I'm left with inches. So 1 meter equals 39.37 inches. Do some multiplication, and you're left with 49 inches per stride. Same type problem. Luis ran 400 meters and 297 strides. Find his stride length in inches. Push pause and try it. All right, there you go. Okay, set up the exact same type of ratio for the rates. Convert your meters into inches, and you're left with 53 inches for a stride. Okay, let's talk about similar figures. Similar figures you learned about in geometry also. They have the same shape, but not necessarily the same size. Two figures are similar if their corresponding angles are congruent. Okay, remember those words? Oh, for goodness sakes. Corresponding angles are congruent, equal. Corresponding sides are proportional. Okay, similar figures. You probably learned in geometry two triangles. Let's try that again. That is awful. Okay. Much better. Okay, I have two triangles that are both right, and they are similar. Okay, side 1, 2, and 3 are similar to 1, 2, and 3. Because I have equal angles, congruent angles, 90 degrees, and proportional sides. And we can do a lot with that. Let's try our first example. We're going to be graphing here. So triangle XYZ has vertices X, Y, and Z at those points on a grid, and XAB is similar to XYZ with a vertex at B0. Graph them on the same grid. So we only know where this point is for this triangle. We have to figure out, we know where X is and B is. We don't know where A is. That's what we're trying to figure out. So they're asking us to graph it, but we don't know where that point goes. So let's figure it out. First of all, we can set up a proportion for this to compare the similar sides. First, we're going to graph triangle XYZ and then draw line segment XB. So if we graph this triangle and then draw this line, we'll be able to figure out where the point A goes. Let's get an x-axis and a y-axis. You might have to rewind a little bit to figure out where to put your points. Okay, we'll do the first triangle in red. So we get x is right here. Okay. 0, 9 is Z, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's where Z is. Y is 1, 2, 3, 4, 5, 6. Yes. Let me double check that. 1, 2, 3, 4, 5, 6. Yep. That is Y, and this is our first triangle. Let's try that again. Goodness. Sorry, guys. That's better. Okay, let's draw our line segment XB. Sorry, that should also go up. Okay, the other one's going to be in blue. XB, we know that B is at 0, 3. So we don't know where A is, but we can set up our proportions. Okay. We know that it's going to share a 90-degree angle, so this will be 90 degrees and this is 90 degrees. So we have similar sides. Okay, XZ is proportional to XB, and ZY is going to be proportional to BA. What is XZ? I believe that is 9. Yep. XB is 3. ZY is 6, and we do not know BA. Do some cross multiplication. 9x equals 18. X equals 2. I probably shouldn't have used X because that is one of our we just need a variable in there. Okay, so this width right here is 2. A is at point -2, 0. And that is what we were looking for. So now we have our other triangle. Alright, you try this one. Graph paper's on the next slide, but push pause and try it on your own. It's the exact same type of problem. Alright, there you go. Your answer. Indirect measurement. Tree in front of Luca's house casts a 6-foot shadow. At the same time, there's our 6-foot shadow, 90-degree angle. Okay, the sun is over here. Rays coming down. That gives us our 6-foot shadow and our 9-foot tree. Doesn't matter that it looks like our 6-foot shadow is longer than our 9-foot tree. My drawings will never be beautiful. We also have a house that casts a 22-foot shadow, but we don't know how tall the house is. 90-degree angle. This gives us our similar triangles. We have congruent angles, proportional sides. And all we have to do is set up a proportion to solve what x is. Okay, we can do x over 9, so house over tree equals house shadow over tree shadow. You just have to keep them in the same order, and you'll always get the same answer. House over tree equals house shadow over tree shadow. Cross multiply. 6x equals 9 times 22. 18, 198. Divide both sides by 6. 6 goes into 19 3 times. x equals 33. So your house is 33 feet tall. You could also do, we did house over tree is house shadow over tree shadow. You could do house over house shadow equals tree over tree shadow, and you'll get the same answer. 6x equals 9 times 22. X equals 33. Okay? You just have to stay in the same order. Let's try the next one. A 6-foot tall climber cast a 20-foot long shadow at the same time that a tree cast a 90-foot long shadow. How long is the tree? Okay, so we have a guy who's 6 foot tall, 20-foot long shadow, 90-degree angle. And a tree is going to be taller. Love my drawings again. Let's keep on going. Okay, that is a 90-foot long shadow, and we don't know how tall the tree is, but we can solve it. Okay, 6 over 20 equals x over 90. I did climber over shadow, tree over shadow. Cross multiply, and we get 20x equals 6 times 90, which is 540. Divide by 20. You have x equals 27. Okay, the tree is 27 feet high. That is it. I hope you understood the practice problems, and we'll work on it more tomorrow.